production planning using linear programming in Microsoft Excel. We'll use this solver function here to solve this problem. So it will it can run numerous amount of equations behind the scene, and then it will give us the solution in a second. Now, to use that, we'll have to prepare Excel in a way so we can basically put everything in that particular function. So this is a typical scenario where you have the demands, forecasted demands provided, regular production cost, overtime production cost, subcontracting, hiring, firing cost, and then overtime capacity, subcontracting capacity is given like this. So first I'll copy this data to a new page so that I can, I have that raw data there, and I'll name this as clean. So we'll have to clean this data in a way. I probably have another clean on, so I'll say clean 2. So we'll have to create some columns here, so then we'll be able to use those in the solver function. So basically regular production, we need one. I'll kind of cut it short a little bit. Inventory, and then overtime production. I'll just write that, and then the subcontracting production, not production, just simply subcontracting, and then number of workers. Number of worker fire, so hire, fire, and then demand constraint, and then the production constraint, then worker constraints. So that's all we need. I'm going to basically, what Excel will do, it will start with 0, and then whatever equation we give them or conditions we give them in the solver function, it will run those calculations, solve those equations behind the scene, and then replace these zeros with the optimum number of production, regular, inventory, overtime, worker, hire, fire, things like that. So first we'll have to create the demand constant. So demand basically will be the regular production in January minus the amount of inventory I would like to have in January for the February, plus the overtime production, plus the subcontracting. And that I will set equal to 600 in the solver function. So I'll leave that constant like that. The second will be the inventory coming from January plus whatever I'm producing in February minus the inventory I would like to have in February for March, plus the overtime production plus the subcontracting production. And then I can copy all of these down like that. And then the production constants are very simple, simply the number of workers times the worker production capacity. In this case, it is given 50 units, so worker can produce 50 units per month, and I will have to freeze that so that I can use it for each of the following months of demand. So I'll simply copy like that. And then worker constant would be, originally I start with number of worker 10 minus the number of fire in January plus the number of hire in January, and then in the 2nd February, whatever worker I have in January plus the number I hire in February minus the worker gets fired in February. Copy that down. And then I need the total for each of these columns so that I can calculate the cost easily. So sum of, I don't necessarily need the demand, but I just want to see. And then I'll copy all the way up to there. The total worker, basically this doesn't make much sense at all. All right, so then let's calculate the cost. Total cost, I'll use this sum of, not sum, so whatever the regular production times the regular production cost, which is $20, plus the inventory times the inventory carrying cost, which is $20, plus the overtime production times the overtime production cost, $30, plus the subcontracting units times the subcontracting cost, which is $40 per unit. And then we also need to add the workers fire and hire. So hire times the hiring cost, which is $500, plus then firing cost times the number of worker fires. So that's the total cost. Now I can run this solver function. So I can go here. Now before I put the constant here, this is my clean data. So I would like to make a copy of this clean data in case if I mess things up, I can always go back to the clean data, which is easier. So after you run this solver, it will basically replace all these zeros. So I will not have this file. So I'll say this is, okay, I think I got another solution. So I'll say solution 2. Oh, that also exists. So I'll name that as solution 3. So solver, it's going to minimize this guy. And then it will basically minimize and then change these variables, workers, hire, fire, not just the total column. And then it will use the simplex function. I'll add a bunch of constraints. First is for the demand constraint. So demand will be exactly same as these numbers here. Then I'll add the production constraint. So this is the production. Will be the exact same as this regular production. Add. And then we can go to the worker constraint, which is the exact same as this worker constraint right here. And then I'm gonna add some more. The workers cannot be fraction numbers, so you cannot just fire half of the worker. So be integer value. Add that, so all of those will be integer. Also, I got a couple of more constant to add. If you look at this here, overtime production capacity cannot exceed the regular production, and then the subcontracting capacity cannot exceed 2,000 units. Maybe there is not enough people available outside your company or somewhere else to buy more than 2,000 units per month. So in that case, you have to hire more workers. So let's put those two constraints. So first is the overtime production will be less than or equal to the regular production. And then the subcontracting cannot go over. So that's going to be less than or equal to 2,000. Like that. I think we put all this constant, hit OK. Now if I hit OK, this should produce the solution like that. So let's double check. Here you can see that the overtime production did not increase the regular production. Subcontracting did not go over 2,000. So like that. If you take out this subcontracting constraint out, then you will see the cost might decrease, and you can just play with these different options. So if you want to, depending on the situation, so if you have unlimited capacity, you don't set that constraint. If you have unlimited overtime capacity with part-time worker and things like that, then you don't set that constraint either. So this kind of give you the whole idea of how to change this problem whatever way you want, and should be able to solve many different problems, combination of these situations.